Welcome back. This lecture is on variability. Just to review from last time. So last lecture we learned about measures of central tendency. These are statistics that describe the middle of a distribution of scores with the goal of providing a single score that is representative of that distribution. And specifically we learned about the mean, which is the ordinary average, the median, or the middle score, and then the mode, which is the most frequent value. In addition to central tendency, it's also informative to describe a frequency distribution in terms of its spread. So variability refers to the extent that scores spread out around the mean. Spread around the mean refers to how close or far from the mean the scores in the distribution are. If the scores are mostly close to the mean, then the distribution has less variability, and if the scores are further away from the mean, the distribution has more variability. What this figure shows is that distributions with the same mean can have very different amounts of spread around that mean. So here we have three different histograms of three different frequency distributions. They all have a mean of 3.2, but with different amount of spread around the mean. Here's another example. So this is a real-life idea which shows two distributions of housing prices in two different neighborhoods. So the neighborhood at the bottom has more diverse housing types, right? So there's different types of houses, different size houses, different number of bedrooms, etc. And therefore, there's more variability in home price. The neighborhood at the top has a more consistent type of housing, and therefore there's less variability in the price. The price of most of the homes are closer to the average. Notice you'll see the dashed vertical line. What that's showing is that the mean housing price is the same in each neighborhood. However, the distribution for the neighborhood with diverse housing types is much more spread out around that mean than the distribution that has a consistent type of housing. So this tells you that there's much greater variability in prices of houses in the neighborhood that has diverse types of housing than with a neighborhood with a consistent type of housing. So again, one take home here is that the mean doesn't tell you the full story. We need to consider both the mean or the average housing price as well as whether there's a low or high amount of variability around that mean. Another idea is that distributions with different means can have the same amount of spread. So what this figure shows are three different distributions that have different means, but with the same amount of spread or variability. So again, the idea is that although the mean provides a representative value, it doesn't necessarily tell you about how much variability there is of the scores. So there are two measures that are primarily used in statistics as measures of variability: the standard deviation and the variance. These are single numbers that will tell us how much scores differ or spread out from the mean. I'll review variance first because we calculate variance in order to then calculate the standard deviation. So the variance is the average of each score's squared difference from the mean. We could also say it's the average of each score's squared deviation from the mean. There's 4 steps for computing the variance. We're going to subtract the mean from each score. Notice that that's a deviation score. We're then going to square each of these deviation scores. Third, we add up the squared deviation scores. And then fourth step, we divide the sum of the squared deviation scores by the number of scores. Let's do an example. Consider the following responses to a survey item. Learning statistics requires a great deal of effort, and respondents could answer on a 7-point scale where 1 was strong disagreement and 7 was strong agreement. So we see we have 5 scores, a 2, 4, a 6, and a 7. So again, we learned last time that we can calculate the mean, and the mean would give us a representative value from this sample about the opinion that this group had about whether learning statistics requires a great deal of effort. What we're also going to do in calculating the variance is we're going to come up with a single number that is able to describe how much spread there is around that mean. So the first step is that we have to, from calculating the variance, was that we have to subtract the mean from each score. So in order to do that, we first need to determine what the mean is. So this will be good review from last time. So recall that our formula for the mean is the sum of x over n. What that formula tells us to do is that we're going to sum up all of our individual scores. So we'll do that. 2 plus 4 plus 6 plus 6 plus 7 is 25. And then we're going to divide by n. N is the number of scores. There was 5 scores, so 25 divided by 5 is 5. So our mean is 5, and that tells us that on average, there's some agreement with this statement. Because if we go back to what the verbal labels were for the values, 5 indicated that somebody would somewhat agree with that statement. So that's a representative value. In our sample, we've kind of on average, people somewhat agree with that statement. Now what we're going to do is calculate the variance. Now what I like to do when I calculate variance and when I calculate standard deviation is I like to organize my work in a table format like this, where the rows are the scores and the columns are the calculations that I need to perform, and those columns are going to represent the steps we need to take in using the formula. So the first step is to subtract the mean from each score. So we've got the scores in the leftmost column. You'll see that I included the mean of 5 in the second column. So the first step is to subtract the mean, and that's what you see I've done in the third column, which is the deviation or the deviation score. So the first deviation of -3 was obtained by taking 2 minus 5 to produce a -3, and I've done that for each of the scores. The second step is to square each of the deviation scores, and so that's what I've done in the fourth column. So 9 is -3 squared. 1 is -1 squared. Recall that anytime we square a negative number, we get a positive number. So squared deviations can only be positive. You must always have positive scores when we square a number. The third step is to sum the deviation scores. So that's what you see that I've done here. So the sum of 9, 1, 1, 1, and 4 is 16. And then the fourth step is to divide the sum of the squared deviations by the number of scores. There was 5 scores, so 16 divided by 5 is 3.2. So our variance is 3.2. So I've shown you the steps and I've shown you the process, and so I kind of wanted to then kind of back in to showing you what the formula. Here's the formula for the variance. It might look kind of intimidating, but really it just reflects the 4 steps that we did, right? So let me show you. So here's the formula. Notice that the first step is to calculate the deviation scores. You'll see that in the parentheses. Order of operations says that we have to do what is ever in the parentheses first. So the first step is to take x minus the mean, that is each of the scores minus the mean. The second step in the formula is to do the exponent, to square those deviations. So that's the second step. The third step is to take the sum of the squared deviations. So remember from last time, we've got this big Greek symbol that looks like an E, but that's a capital Greek letter sigma. That means take the sum. So that third step is that we take the sum of the squared deviations. And then the fourth step is to divide by n. Another way to rewrite this formula is to simplify the top of the formula. Okay, the top of the formula is the numerator. So we can simplify the numerator as simply SS, which stands for sum of the squared deviations from the mean, or just sum of squares. So in this class, you'll see the formula written both ways. They're equivalent. The bottom formula is just a simplification of the top. It's a shorter way to write out the formula, is rather than writing sigma parenthesis x minus the mean parenthesis squared, we can just write SS for sum of squares. We know that that means the sum of the squared deviations from the mean. Okay, so let's try to interpret this variance of 3.2. Unfortunately, this number is not especially meaningful in and of itself. In fact, the variance is very rarely used as a descriptive statistic. The reason is that the variance is based on squared deviation scores, which doesn't give an easy to understand sense of how much those scores spread out from the mean. Recall that the variable here was measured on a 7-point scale, 1 being strongly agree, 1 being strongly disagree, 7 being strongly agree. So we now have kind of that response scale where the scores have been squared, and it kind of no longer makes sense. It's hard to understand what the original metric is now that we've squared the scores. So for that reason, the most common measure of variability to report in a research report is the standard deviation. The steps for computing the standard deviation are very straightforward once we figured out the variance. So the first step is to figure out the variance, and then the second is to take the square root of the variance. So in this case, in this example, our variance was 3.2. The standard deviation is calculated by just taking the square root of 3.2, which gives us a number of 1.79. So calculating the standard deviation is really just one additional step after calculating the variance. Okay, calculating variance takes 4 steps. Calculating standard deviation takes an additional 5th step, which is to take the square root of the variance. You'll see that I've included the 5 steps here. They're all the same as the variance. In the upper right-hand corner, I've just included the formula for standard deviation, which is exactly the same thing as the variance, only the entire formula is square rooted. It's also important to know that just like the variance, the standard deviation is also based on figuring out the deviations from the mean. That's what the variance did, and because the standard deviation uses the variance, that's what the standard deviation does. Essentially, what we're doing here with the standard deviation is we're reversing the squaring process that happens at step 2. We took all the squared deviations from the mean, we took the sum and then divided, and so then we just take the square root, which ends up undoing that squaring process. You might ask what the point of that is. Why do we square all those deviations only to ultimately unsquare them? The reason is, as we learned in the previous lecture, that the sum of the deviations from the mean will always sum to 0. So if you look in the third column, you'll see the deviation scores of -3, -1, 1, 1, and 2. If we add those up, we can see that those deviation scores sum to 0. And that's always going to be true because that's a property of the mean. The deviation scores from the mean always sum to 0. So if we want to have a statistic that's based on being able to kind of understand or capture how much the scores deviate from the mean, we're always going to be in trouble because the deviation scores sum to 0. So what the variance formula does is square the deviations in order to only get positive numbers. So when those positive numbers are added, you'll get a number that is not 0. So it's a little bit of a mathematical trick to take the deviations and square them, add them up, divide by n, and then unsquare the process is a way to get a sense of how much those scores differ or deviate from the mean. Okay, so we can interpret the standard deviation as the average amount that scores differ from the mean. It's important in this definition to recognize what the standard deviation is not. The standard deviation is not the average amount that scores differ from each other. The standard deviation is the average amount that scores differ from the mean. Again, with variance and standard deviation, we're trying to capture spread from the mean. Here's the formula for standard deviation. I should note that the textbook also presents a computational formula, which looks a little different. Please ignore the computational formula and focus on the definitional formula. I think that the definitional formula is much easier to understand, and the formula fits the definition for standard deviation in words. What you can see, and what I hope you understand from this formula, is ultimately what we're capturing is the average of the average deviation from the mean. Okay, and then we can just compare the variance and the standard deviation side by side. Notice that they're very, very similar, and I often think of the variance and the standard deviation as being two different sides of the same coin. They basically tell you the same thing. They tell you how much variability there is in a distribution of scores. And you can't have the standard deviation without the variance. You have to calculate the variance in order to calculate standard deviation. So they're really, they're very closely related. If you have a high variance, you'll have a high standard deviation. If you have a low variance, you'll have a low standard deviation. So they're very much the same, and we'll be working with both variance and standard deviation, but for the purpose of reporting a descriptive statistic, in order to describe to a reader or to an audience how much variability there is in a group of scores, the standard deviation is the statistic that is reported. Okay, again, definitions. The variance is the average of the squared deviation scores from the mean. We can see that in the formula itself. Notice that the formula for the mean from last time was sum of x over n. So that idea of an average is really captured here. What we're averaging by taking the sum of something and then dividing by n is we're averaging the rest of the formula. The rest of the formula are those square deviations. So the formula matches the definition in words that the variance is just the average of the squared deviations from the mean. The standard deviation is the square root of the variance, and the conceptual definition or the conceptual understanding of what standard deviation is is it's the average of the deviations from the mean. Okay, again, we've just unsquared that squaring process, so we can just think of this as the average deviations from the mean. I also want to point out the standard deviation doesn't tell you what the distribution looks like. It doesn't tell you the shape of your frequency distribution. In all four of these distributions that you see pictured here, the mean is 4 and the standard deviation is 1. But they all look very different, don't they? In some cases, we have a unimodal distribution. In some cases, like in the upper right, we have a bimodal distribution. In some cases, we've got a symmetrical distribution. In the bottom left, we've got a skewed distribution. So really, all three pieces of information are important. We need to know a measure of central tendency. The mean is most often used. We need to know a measure of variability. The standard deviation is most often used. And then it also helps to actually take a look at a graph, like a histogram, to get a better understanding of the shape of the distribution, to understand whether it's symmetrical or whether it's skewed. Just to give you a sense of how descriptive statistics are reported in published research, here we see a table of descriptive statistics that was adapted from a research article on social media usage. And this article is rather old. It was published in 2011, over 10 years ago, and that explains why the social media platforms that they were researching were Facebook and MySpace. But it serves for the sake of illustration. It's important to make note of what using both the mean and the standard deviation can tell us when they're used in conjunction. So just to orient you to the table, so the rows of the table are the different variables that they collected information on. They looked at how long their participants had been a member of the platform, how many times the platform was used per day, minutes spent per use, and total minutes per day. So those are the four variables. We see that the more left columns are for Facebook, the more columns on the right are for MySpace, and then we see three different statistics. We see the mean, the median, and the standard deviation. So what are the types of things that we can learn? Well, one, for example, we can see that on average, Facebook users use the platform 1.2 times a day, and there was a standard deviation of 1.3. So this indicates that most people indicating that they're using Facebook once a day and maybe a couple more times, but on average just over 1, and that there's a fairly small standard deviation, so that scores only deviate from that mean by about 1.3 on average. So we could say that there's fairly consistent, that users are fairly consistent with how much they use Facebook in terms of the times that they go on Facebook per day. On the other hand, however, when we look at the total minutes per day, the mean is 39.1 with a standard deviation of 77 minutes. That's a much bigger standard deviation, and that suggests that there's quite a bit of variability among users in how much time they spend per day. So there's some users that spend many minutes and probably several hours per day, and there's some users that might not spend that much time at all. What we can also pick out from the relationship between the median and the mean, notice that the median is 15 and the mean is 39, is we can get a sense that this distribution of scores is skewed. Remember that in a skewed distribution, the mean gets dragged in the direction of the skew. So here the mean is higher than the median, which indicates that the mean is getting dragged into towards the tail or the skew of the distribution. So what we likely have here, and that's also reflected in a large standard deviation. So even though we don't have the picture, we don't have a histogram, and it would be better if we did, based on what we know, about our measures of central tendency, as well as our measure of variability here, we can get a sense that this is a positively skewed distribution, with most of the scores piling up around the median, right? So that kind of a more typical usage is 15 minutes. But then based on that high variability and the mean getting pulled uh, to being a higher value, we likely have a smaller number of participants that when they go on Facebook, they're using it many minutes a day and probably even hours. Okay, so I just wanted to go over one other measure of variability, which is the range. This is not covered in the textbook, but it's a very simple statistic, and it's a good one to know. So the range is simply the number of values over which a distribution spans. We calculate the range as the difference between the highest and the lowest value. So if we had a low score of 1 and a high score of 100, the range would be 99. Okay, and then I'll just leave you with some practice. So you can take a minute here to determine what the mean, the variance, and the standard deviation of this set of scores is. And I'll review the answers on the next slide. So if you want to pause now and do the calculations, I'll share the answers on the next slide. Okay, so here are the answers. So first, to calculate the mean, we take the sum of the scores divided by the number of scores. Sum of x is 18, which makes the mean 4.5. We're then going to use 4.5 to calculate our deviation scores, our squared deviations, the variance, and the standard deviation. Notice here too, I've organized my work into this table format where the scores 2, 4, 5, and 7 are the rows, and then I've used the columns to perform the calculations. Okay. Again, the process is to take the deviation from the mean, to square those deviations, to sum the square deviations. Notice here that I've included that the sum of the square deviations are abbreviated as SS. Sum of square deviations is 13. To get the variance of 3.25, I divided 13 by 4. And to get a standard deviation of 1.8, I took the square root of 3.25. Okay, so hopefully that was helpful practice, and hopefully after this lecture you have a better understanding of our measures of variability, variance, and standard deviation.